This question involves graphing on the Cartesian plane, and it has many parts to it. The first part asks us to calculate the magnitude of the vector AB. Well, we see AB is drawn here because A is at -3, 2 and B is at 2, -1. So to determine the magnitude, we can use the distance formula or think of it as a Pythagorean theorem opportunity. And we see that d squared will equal 3 squared plus 5 squared. So the answer is root 34. The magnitude of AB is root 34. Okay. Now we want to determine the coordinates of point D on vector CD if C is at -5, 1 and the two vectors equal each other. Well, AB represents a journey of 3 units down and 5 to the right. So starting at point C, we'll go 3 units down and 5 to the right. And we'll see that we end up at point D, which is the point 0, -4. Right there. Next, we want to determine the coordinates of point E on the vector if F is 5, 0 and EF is AB. Well, this is interesting. It gives us the ending point instead of the starting point. Well, if a journey from A to B represents down 3 and right 5, going backwards would be left 5 and up 3. Well, going left 5 and up 3 from the point 5, 0 gives us the point 0, 3. And finally, we want to know the coordinates of point H on this vector if G is 4, -6 and GH is -AB. Well, this is almost like giving us the ending point, thinking of it that way. G is 4, -6. Now, 4, -6 is here. Now, GH is going to be -AB. So if AB represents down 3 and right 5, then -AB is going to represent up 3 and left 5. So traveling from the point 4, -6, up 3 and left 5 gets us to point H, which is at -1, -3. And we do that, one way to do it is by counting squares when we're first learning vectors.